Hello, my lovely students. A very warm welcome to all of you. And I hope you all are excited enough for this third session of Carbon and its Compound 2 because you were requesting me, ma'am, please finish this chapter ASAP and let's start the new one so that we'll be able to finish the entire CBSE 10th and we'll be able to have revision also. So don't worry, your Anubha Ma'am is here to help you all out. And I'll try my level best to give you all possible insight with all the possible questions as an important questions I'm going to tell you that can come from this topic will help you. So stay till the end and do not miss even a single minute of the same. Alright, this is session number 3 where I'll talk about hydrocarbons and homologous series in detail. Trust me, this is the most important topic of this chapter this year because of our corona situation, and as you know, only 20% syllabus is there for this year to study. So I hope you are with me, with your AG ma'am, and you are enough motivated and enough excited that yes ma'am, we can do it. And yes, it's possible now also. If you'll start managing your schedule, if you'll start giving your best, it's possible now also to get 90%. So stay with me and let's learn about this topic of chemistry in detail where you know the topic. Okay, so let's do this thing. What's this? Exercise of our mind. All right. So without any further ado, let me take you to the topic hydrocarbons and let's discuss each and every approach. First of all, why we are studying hydrocarbons. As you know that this chapter is knowing organic chemistry in detail, and organic chemistry is what not only limited to the things that is there in all the living beings. Earlier this was the theory that whatever we are getting from living beings is the only one that's organic, but Friedrich Wöhler changed that theory and told us, I'll give you a better approach because you can prepare organic compounds in laboratory too. So you can call organic compounds as what from now on? Hydrocarbons and their derivative. What exactly is hydrocarbon? As the name is suggesting you, hydrogen and carbon. Something like what? So a compound that's made up of carbon and hydrogen is called as hydrocarbons, definitely with some fixed chemical formula. And its derivative will be organic. Derivative means something that's derived from hydrocarbon. Something that you have a hydrocarbon, you remove a hydrogen because it's easy to remove hydrogen. Hydrogens are those flexible one and can go and will be replaced by some atom or group of atom over there. Okay, so hydrocarbons is clear. First of all, we'll talk about hydrocarbon. Then we'll move to the second part. Alright, so what is the general formula for hydrocarbon? I think it's pretty obvious. There will be some X atom of carbon and Y atom of hydrogen. I'll tell you all the possible formulas that will help you to remember hydrocarbons in detail. First of all, hydrocarbons are parent organic compounds. Means without hydrocarbon, my organic compound is not possible somewhat. Like I am going to have a long carbon chain and who will accompany these carbons? Nothing but hydrogen. So whenever we have an organic compound that trust me, will be having a carbon chain as a backbone and having hydrogen attached to it. So it's more of like a parent hydrocarbon. Okay, something that's necessary. As if we all are having a same skeleton but we look different. All of the carbon compounds will be having a carbon chain along with hydrogen knowing as a parent chain, and something that can be derived from attaching to this parent chain. Alright, so as I told, something can be replaced, that is hydrogen, with some other atom or group of atom. I can tell you an example where what did I do? I hope you have seen previous 2 lectures as well where I did talk about how the bonding in hydrocarbons occur. Okay, if you haven't seen that, please, that's quite important. After the session, you can see the entire series of lectures. So here, as I told you, chlorine is like, hey hydrogen, will you go so that I can come? Hydrogen is like, not that easily. I need a partner so that it's easy for me to go. I have a reason. Okay, so hydrogen will take this chlorine and went away. I have a position with carbon to attack. So chlorine is like, okay, I got a new place and I can attack here. And you can see that. ma'am might be sounding a bit different. I don't know. It's there in my head. Maybe I'm having a very bad cold, so it's like I can hear my own voice. All right, everyone, let's get back to the topic. You can see hydrogen went away and chlorine come. That's what I got, a derivative of hydrocarbon where hydrogen is replaced here with the chlorine. And do remember, when I replace my hydrogen with the chlorine or maybe any halogen, halogen is 17th group of periodic table, a member that can combine with the metal to give salt. Halo means salt, gen means generator. Halogen salt generator that makes salt with metals. So that's what it is. And for halo, whenever I'm having in a compound as a derivative, it will be written in very starting as a prefix with the sound of O. So it's like hello. So chlorine will become chloro. And I'll write it in very starting. They act as prefix, something that will be numbered in very starting. So this is what, students? Methane. Why? One carbon with 4 hydrogen. I'll talk about that later in the session too. This is methane. When one hydrogen is replaced with chlorine, so that became chloromethane. All right. So methane becomes chloromethane by a replacement of hydrogen. I got a derivative. So this is something I can tell you about a hydrocarbon and its derivative in very short. We'll talk about now different type of hydrocarbons too. And one is saturated, which has saturation. It's like, ma'am, you're teaching us, small kids, you're teaching us from 2 hours. That's too long. Now, our mind is somewhat saturated. Saturation means nothing can be added. So with these hydrocarbons, when you have a single bond between carbon and carbon, nothing can be added to those carbon because there's no space. Single bond is saturation. Okay, saturated with a single bond. Unsaturated, they are telling that, ma'am, you're so sweet and you're doing that much hard work for us, and from past half an hour is just over that you started teaching. I can sit in your class for even 2 hours. I'm feeling so unsaturated. Yeah, appreciating that. So unsaturated, where carbon-carbon double bond and triple bond is there. Unsaturated means in which addition is possible. So with the double bond and triple bond, there can be addition of some group of atoms so that these bonds starts breaking and I'll reach up to saturation. So addition is possible up to saturation. There is a very important thing I told you here. Okay, so saturated with a single bond called as alkanes, unsaturated with a double bond between carbon and carbon, alkenes, with a triple bond between carbon and carbon, alkynes. So I have these 3 type of hydrocarbon that you should know: alkanes, alkenes, alkynes. So ma'am is telling you one very important thing here. Let me take another color pen, and yes, alkanes. Did you see the formula? CnH2n plus 2, and is just a whole number starting from 1, 2, 3, 4 and so on. The thing that I want to tell you, that alkane is carbon-carbon single bond. If you want to achieve carbon-carbon double bond, single to double, okay, just do remember, whenever you are writing a compound, carbon should always make 4 bond. That's what tetravalency for carbon, and that must satisfy. Then only it will be able to follow its octet rule. So when carbon has to make a double bond from single, what will happen? One atom from here and one atom from here has to go away. Then only double bond can come, and those atoms in hydrocarbons are nothing but hydrogen. So alkanes are having a formula CnH2n plus 2, but alkane, I am going to double bond, so 2 hydrogen must be lost. So alkane's common formula will be CnH2n. See, there's a difference of 2 hydrogen. Now let's move to next step. And now there will be two hydrogen here, knowing to the fact that carbon has to make 4 bond. Now I am moving to triple bond. All right, for triple bond, for one more bond, I need to remove these 2 atoms to those 2 hydrogen extra, so that a triple bond can come and valency of carbon will be satisfied only with 1 hydrogen attached here. So what did we see? 2 more hydrogen has to be lost. So formula will become CnH2n minus 2. So we have a particular reason to remember the formula. So many students were asking me from so long, ma'am, we didn't get it. Why these formulas? I think you have a proper reason now. CnH2n plus 2 single. For making a double bond, 2 hydrogen must be lost. So CnH2n. For making a triple bond, 2 more hydrogen has to be lost. So CnH2n minus 2. Alright, pretty clear? Do let me know and keep hitting the like button. Please share it to all your friends and just tell them that how Vedantu is such a lovely platform and you all must come here and support this channel equally by all possible means so that we can make it a big hit and we'll get motivation that you guys are coming and supporting. So, we'll be motivated to do more and more for all of you. Alright, so let's start with saturated hydrocarbons, saturated carbon compounds. As I told you, that means valency of carbon will be satisfied by making carbon-carbon single bond. With itself means carbon and hydrogen always makes single bond. Please never forget that. And they're non-reactive. As I told you, they're like, we are already saturated. Why will we react with anything else? So they are not very reactive. They'll be there in the nature in the free form only. And the simple form will be CnH2n plus 2 and a whole number, and I'll start putting in is equal to 1, 2, 3. And what will I get afterwards? Just see that. If I put n is equal to 1, I am going to get C1 and H4, right? And I can simply write it what? C1, I can write it C. So first member is CH4, second C2H6, C3H8, C4H10 and so on. I hope there's no denying in the fact. I'm following the formula. Hydrogen must be double of carbon plus 2. And there's one common thing you also observe that whenever you talk about all the members of alkane, there is a common difference in all the member of CH2 group, right? One carbon is extra and 2 hydrogen is extra all the time. Yeah, that's true and will always follow. Okay, and what exactly is this substance? Like how we can name any alkane, alkene, alkyne, any organic compound. So IUPAC, International Union of Pure and Applied Chemistry, gave us certain rules. And what are all those rules, students? That you need to remember that as we have a skeleton, that's pretty important. For hydrocarbon, that skeleton is number of carbon. And we call it word root. Root, word or word root, both will work. That means the number of carbon has a particular name to mention it, to tell it. Okay, that's word root. That means the root, that means the backbone. That gives us number of carbon. And after that, we add a suffix. Suffix means that comes after. Prefix means that comes before. Suffix is of two types, primary and secondary, and after mentioning number of carbon, I'll start by adding primary suffix, and that is what? That tells us about bonding between carbon, that is that single, double or triple. For single bond, we end it with ane. For double bond, we end it with ene. For triple bond, we end it with ine. Okay, ane, ene, ine. So suppose I have one carbon. For one carbon, we have a fixed word root, and then after that we'll write ane, ene or ine depending upon the nature of bonding between carbon and carbon. And secondary suffix is what? Whenever you are having your alkane, alkene and alkyne simultaneously, that's number of carbon and primary suffix. After that, if hydrogen is lost and some other atom or group of atom is added, then that atom or group of atom is what? Your secondary suffix, and will be named in the very last. And that is nothing but your functional group. Name is giving some information. Functional group, a group that's very much functional, a group that's deciding the chemical properties when attached to a hydrocarbon. Okay, just like alcohol is a functional group, and that's saving us from corona nowadays too. Not 100%, but yeah, prevention is better than cure. Our sanitizer, yes, so that's one of the type of functional group only, alcohol, and we'll talk about that later. Prefix is something that's written in very starting, and as I told you, if I have halogen, that always act as prefix. That means we'll always name in very starting. So as cyclo, what is cyclo? When I have a chain of carbon attaching to each other in a closed loop, in a cyclic manner, then I will end a cyclo in the very starting too. Okay, we'll talk about that aspect too. I hope this part is clear and it will be making more sense to you when I'll give you enough example. So don't worry, you do not need to fear because your Anubha Ma'am is here. So let me start giving name to it. You can take screenshot, you can download the entire file, you'll get the link in the description box too. And right now I'm taking an eraser and cleaning the space so that I can write the name given to it. And that's done. That will work for us. Oops, some extra things also raised out, you know, blooper in the class. Not exactly, yes. For one carbon we use a word root, that's meth, and as I told you, a suffix ane. Why ane? Because that's following a formula of alkane. So the very first member of alkane family is methane. That's there in your CNG2, compressed natural gas, that we use as a fuel, 95% methane. For two carbon we use eth, and following an alkane formula we'll end it with ane. Ethane, then propane. For 4 carbon we use bute, so butane, and so on. I'll tell you the next member that's written here. Excuse me, yeah. 4 bute, so butane. 5 pent, pentane. 6 hex, hexane. 7 hept, heptane. Never say septane, that's heptane. Okay. 8 oct, so octane. 9 nonane. I don't know why I always find that funny. Nonane. And 10 dec, so decane. That's enough for you. There are many more, but for 10th class that's enough. And now we learn how to write the structure of alkane in the possible way. Like if someone will tell write their electron dot structure, write their open structure, and write their condensed formula, you must know that. Okay. So first of all, we'll talk about the open structure formula. Ma'am, big word, nothing like that. Open structure, name is giving you answer. You will represent all the bonding of carbon and hydrogen, open structure. So for methane, we talked about that in organic compounds, covalent compounds in very first lecture too. Methane, meth for 1 carbon, and you know that always valency of carbon is satisfied, that's 4. And that is getting satisfied by making a single bond with carbon, I mean hydrogen, because hydrogen always make a single bond. Why? Because it has to follow its duplet, 2 electron rule. It has 1, it will share 1 so that it can make a single bond. Now we'll talk about ethane, that's more important. It's for 2 carbon, how to draw open structure, write a bonding between carbon and carbon, then write hydrogen accordingly so that every carbon must make 4 bonds. Okay, so I drew a carbon-carbon single bond. Now I will write 3 hydrogen here and 3 here. The reason is what, students? The reason is carbon must follow 4 bond, and always start by making a carbon chain, carbon long chain depending upon number of carbon, and always make a single bond because alkanes make a single bond. Now there's suppose I want to draw now propane. What will be propane? Prop for 3 carbon, I'll write in this way, and formula will be what? Hydrogen is double plus 2, so this, and you're not even counting, you just started writing just to follow the valency of carbon, that's 4. All right, and ultimately you will get the right formula. 3 hydrogen, because then only carbon will make 4 bond. 2 hydrogen, then only carbon will make 4 bond. And you can remember in one more possible way that terminal carbon will be always CH3, only works for alkane. Terminal carbon, like the carbon that's in the end, will always be CH3, middle carbons will always be CH2. In that way, I can also write one more way of writing a formula called as condensed formula. Condensed formula is what? Where I am writing all the carbon's backbone and writing hydrogen all together. Suppose I want to write formula for ethane. I'll just draw a carbon chain and I'll write hydrogen in a condensed way, means all together. So this is having 3 hydrogen, CH3. This is having 3 hydrogen, CH3. Don't ask such a question that, ma'am, should we write here or here? It's totally up to you. Teacher will not make it wrong at all. So for this, how will we write 3 carbon chain in the similar way and write hydrogen all together? As ma'am suggested, terminal always CH through 3 and middle always CH2. Okay, so now you know how to draw open structure and condensed structure too of alkanes. And there's one more way that's simple, is molecular formula, where I'm writing all the carbon and hydrogen like this all together. So this formula is called as molecular formula, molecular structure, open structure, and then this is the way I'm writing condensed formula, condensed structure. And the last one is electron dot structure. Means you can write a compound with 4 possible way in organic chemistry. I think it's very interesting. I find it very interesting. I hope with the time, when you'll start doing enough practice, you'll start loving it. And methanes, students, you know, I'll tell you a trick. Whenever you try to draw electron dot structure, try to be a bit smart. In what sense? You know the open structure. In corner, just write open structure. And you know that single bond is formed by, you know, sharing of 2 electron by the 2 atoms involved. So just do one thing, write in very corner the structure, replace bond with these electron dot, and then try to or pretend to draw the structure. In what way? That I have carbon that's attached to 4 hydrogen, and what exactly I'm doing, I know every hydrogen is having 1 valence electron. Electron dot structure is writing the valence electron of the atom in form of dot on the symbols included in the formula, and then starts making the circle to justify or to follow the octet rule, except for hydrogen that always follows duplet rule. Alright, hydrogen has 1 valence electron, but carbon has 4. In a way, I'm just imitating this structure in this way. And then I need to make these circles. These are called as electron cloud. Means how electrons being shared with the other atoms. Sharing is caring for organic chemistry, for carbon compounds. Hydrogen will always share 1 electron with carbon because it has 1 of its own, and sharing 1 is helping it to complete its duplet, and they are stable. And carbon, and this kind of a sharing is mutual. A carbon will say to the other atoms that if you are sharing something from me, you have to share equally. Okay, so 4 of its own, and then 5, then 6, then 7, and then 8. Yeah, mission accomplished. And look at this, carbon is having its 8 electron octet complete, hydrogen duplet complete. Now just do one thing, just make these lines. What this is, hydrogen carbon share 2 electrons with each other, leads to a single bond, single bond, single bond, single bond. Sounds like jingle bell, I don't know why, but yeah, true. So this is your methane, and you know that how they have single bond between carbon and hydrogen. In a similar pattern, now you can draw for ethane too. I'm writing the simple structure which I told you, open dot structure, and try to pretend that you're drawing the structure, but just write the structure in the same way. Make their just, you know, replace these dash line with the dot, that's valence electron, and start making those circles. That's it. That's what you need to do, and I know you will succeed. Not at all difficult. So now you know how to draw alkanes with all the possible formulas, and you have mastered this tiny topic. Now let's move ahead and talks about unsaturated hydrocarbon too. Unsaturated, as the name is giving you answer, there is unsaturation. Unsaturation, double and triple bond, and that's of 2 types. That's alkene and alkyne. And as I told you, when we talk about alkene and alkyne, they are comparatively more reactive, knowing to the fact they are more exposed to the atmosphere, and different atoms can come and attack here, so that a saturation will be achieved. All right, so yes, that's what they are. And now we'll talk about alkenes and alkynes one by one, and we'll try to draw the structure also. But first of all, let's talk about ethene. In what sense? We'll talk about its common formula. Alkene's common formula we know, CnH2n. Alkyne common formula, CnH2n minus 2, and I told you the reason too. Now there's only one thing that you need to pay attention of, and that is here, and will always start from 2. Here N will always start from 2. The reason is, let's try it out. If I put N is equal to 1, what did I get? C1 and H2, right? If I put N is equal to 1, what did I get? C1 H2 into 1, 2, 2 minus 2, 0. And that is just carbon. Now look at the structure. You know that ma'am already told you carbon must follow 4 bond, carbon's valency is satisfied. By drawing this structure, carbon is not making 4 bond, carbon's valency is not getting completed. Then why carbon will make a compound when it's not even stable? So this is not the correct formula, because carbon always makes 4 bond, means octet will be completed then only. Not possible. And here it's like poor carbon, loner carbon, how it will make a triple bond, that's alkyne, how it will be following its octet. So alkenes and alkynes will not start with carbon 1 but start with carbon number 2. So if I want to tell you the formulas of different I should say alkenes and alkynes, how we'll start. First member will be 2. So C2H4, here C2H2. This is C3H6, here C3H4. Can you know the reason what ma'am is trying to do here? For alkenes, hydrogen is double. For alkyne, hydrogen is double minus 2. So can you tell me the name of such compounds? I think you can. Why? I told you the general nomenclature rule. First of all, we'll define the number of carbon with the word root, then add my required suffix, that's ane, ene or ine. So this is ethene and this is ethine, right? But I can tell their common name too. Common name is written in bracket, just like your Anubha Ma'am. You with so much love call me AG Ma'am, Anu Ma'am and whatsoever. So in the same way, ethene has a common name too. That's also called as ethylene. That's a gas. We call it ethylene gas. You can also call it ethylene. It's totally up to you. Different people, different pronunciation. Ethine is commonly called as acetylene or acetylene. The way you want to pronounce it. More common names you do not need to remember. That's what is important. That's what I am telling you right away. Ethylene and acetylene or ethylene acetylene. That's it. That's it. 3-prop. Ene, butene, pentane, pentane. Now you know how to make pentane. You do not need to get the shampoo pentane. You can prepare it by yourself. Just a joke. 3-prop but ine, propine, butine, pentine, and so on, hexine, heptine, octine, nonine, and decyne. Now you know you have mastered it. Ma'am told you to draw the molecular formula too, but what is also important, to draw their open structure and to draw their electron dot structure of the common and the normal one, normal alkene and normal alkyne, the lower member one. Okay, so that I'll draw. I am removing this, I am erasing this. You can take a screenshot, you can download it as well. Alright, now we'll talk about how to draw the structure of ethene. And I tell you, what did I tell you? That how to draw first of all open structure. For open structure, the rule will be same. First, try to draw my carbon chain. Try to draw my carbon chain. And second thing, what? Try to draw my carbon chain as it's eth2 carbon. Ene means alkene and alkene always means a double bond. The formula that ma'am told you, CnH2n, for alkyne CnH2n minus 2, that will only hold true when you're talking about only putting one double bond and one triple bond. If you put more than one, then the formula will be changed completely. So do remember that. So alkene, here is ethene, 2 carbon, ene means a double bond. Then you can put hydrogen accordingly, knowing to the fact that hydrogen always makes a single bond. How much hydrogen? 2, 2. Reason is because carbon makes 4 bond. And how to draw its electron dot structure? Very simple. You just imitate the structure. In what sense? I'll draw it like this. I will see that how they are making bond, writing their valence electron, And for this carbon, I'm writing on this side, so that my diagram will look neat and clean. Hydrogen sharing 1 electron, that's what we needed. And carbon is our master. Carbon is like whatever you are sharing, and I'll share equally, because equality is good. So carbon is like, I'm having 4 of mine. 1, 2, 3, 4, 5, 6. Oops, 2 electron less. So that this carbon will be like, okay, I am also your friend. You can take from me and we can bond with each other. Bonding. Whoever is in the close proximity, they only will combine. Same job it will do. Carbon with the what? 4 electron, 5, 6. Equal. Equality. Sharing is caring. That's what I did. I drew the structure of ethene in front of you. And do not forget to what? To make bonding. Like, ma'am, you wanted to say, do not forget to subscribe the channel. Yeah, that's true too. Single bond, single bond, single bond. Okay, I'll try not to sound like a jingle bell. And here that's a double bond. Why? Because 2 electron shared, single bond, 4 electrons being shared between 2 atoms, a double bond. And my job is done. Not for this class though. I hope you're able to understand it. Okay. So alkene is pretty much clear, but only a lower member. What about the higher member? What if I will tell you to draw the structure of propene, butene, pentene and so on? Please remember one thing. How will you draw? Prop 3 carbon, first of all I'll do this job. But 4 carbon, first of all I'll do this job. Then ene, a double bond. Where to put a double bond here? Always remember that with the star mark, always remember that you'll always put a double bond at terminal carbon. A double bond, a triple bond, always at the terminal carbon. Means the last corner ones. Okay, either from the left side, from the right side, because it's like giving priority to double or triple bond, that whenever we put in the very extreme corner, I have a choice to start numbering carbon from any of the corner. Okay, what did I say? When I have a carbon chain, I can count from left to right the entire carbon chain, or right to left the entire carbon chain. I'll do from that side of the carbon chain, from where I'll get my double bond or triple bond at a lower number of carbon, at the lowest position of carbon. And we call it what? That giving priority to their children. For a carbon chain, that's parent chain, these double triple bond are acting as their children. Okay, and children needs priority. So whenever I have to put triple bond or double bond, I'll always put it to either this carbon or this carbon. This carbon or this carbon, totally up to me, because then it will be my choice that from where I am counting, left to right or right to left. And then you can put hydrogen accordingly. I hope there's no denying. I can draw hydrogen for you too. Look at here, carbon making 2 bond, 2 hydrogen. Carbon making 3 bond, 1 hydrogen, single bond, 3 hydrogen. Why? Carbon makes 4 bond. 1 bond, 2 hydrogen, 3 bond, 1 hydrogen, 2 bond, 2 hydrogen. It's making 1 bond, so 3 hydrogen. And you can check the formula too. Propene will be C3H6 and butene will be C4H8. So as your pentene and so on, so on. You can see these structure too. They have put the double bond on this side. I can consider this as my first carbon, and I can consider this as my first carbon too. Either from right to left or left to right, it's totally fine. Same with alkyne. And what's that? Carbon-carbon triple bond, quite reactive, as more exposed to triple bond is more exposed to atmosphere, as in for the space to attack, and very much reactive for the same reason. And as I told you, alkyne will also start with carbon number 2. So the very first member, according to the formula CnH2n minus 2, this is the very first alkyne. Okay, and I told you how to draw its electron dot structure. Write carbon chain first of all. Alkyne means a triple bond, as I discussed, and then put hydrogen accordingly, not like a rocket science. And 3 carbon, 1, 2, 3, putting a triple bond, same reason, either this way or this way, totally up to you. My choice that whether I'll count from left to right or right to left, The only thing is priority must be given to double or triple bond, means I'll start counting from that side. Parent. And these are acting as like children. One hydrogen here. This carbon already making 4 bond. No hydrogen here. And here 3 hydrogen. Here 3 hydrogen. Here no hydrogen. And here 1 hydrogen. This is same only. And this is what? Propyne. What do we call it? Propyne. So as butane, 1, 2, 3, 4, 4 carbon, and then putting a triple bond at the very first carbon, and then write hydrogen accordingly, so that carbon will make 4 bond. Alright. So this is about alkane, alkene and alkyne. But is that the only part of hydrocarbon? Not at all. It's not that simple. We have chain hydrocarbons that I did tell you, where we have a straight chain of carbon. We can have branched hydrocarbons too. What exactly is branched hydrocarbon, students? Branched hydrocarbons is something that when I have a straight carbon chain and having hydrogen too all over it, knowing to the fact that again valency of carbon, that's 4. When some of the hydrogen is replaced, some of the hydrogen is gone from an alkane, and some other atom or group of atom we are getting, that could be functional group. But there is also one more thing, and what exactly I meant to say by the same, that from alkane, whenever we remove a hydrogen, the formula will become CnH2n plus 1. Alkane's formula CnH2n plus 2. If I remove a hydrogen, CnH2n plus 1. And alkane is now called as alkyl. And alkyl is nothing but having a carbon that's following incomplete valency, and they can be attached to any of the carbon chain and can acting as a substituent. Okay, that could be very simple. Suppose I have CH4, I removed a hydrogen and I got now CH3. Having this carbon with incomplete valency called as alkyl group, 1 carbon, so methyl group. My carbon chain, and if some of alkyl group is attaching to my parent chain, my carbon chain, that chain will become branched. So suppose, let me draw a structure for you. Yeah, suppose I have this carbon chain, CH3, CH2, CH3. I remove this hydrogen and I'll be like, as one of the position is still there, what will I do? I can put my alkyl group here. I can put my alkyl group here. How come? I can put my CH3 here. Alkyl group. This became like this. Right? I'm writing its what kind of a structure? My condensed structure. This CH3 is more of acting like a branch. My main chain having some branches. Branched hydrocarbon. And good part is nomenclature is not there for branched hydrocarbon according to your books and for your syllabus of this year. So this will be pretty easy, but at least you should know what is alkyl group, and that you know clearly now, right? By overcoming or by removing 1 hydrogen from alkane, we got our alkyl group. They always act as substituent. Substituent means something that's attaching to my main carbon chain, and always act as prefix to, will always give numbering in very starting. So my methane become methyl. I'll always end it with "-ile". Okay, methane become methyl, ethane become ethyl. This was ethane. 1 hydrogen less, ethyl. Propane became propyl, butane butyl, and so on. All right. So this is alkyl group. One more category, that was branched hydrocarbon. There's one more category of hydrocarbon where I have my carbon chain, and when I spoke about terminal carbon, now we see one more thing, that terminal carbon is attaching to itself and making a cyclic chain, as if you are making a garland and you just put all the flowers and just tie a knot. All of the flowers are in a straight, in a ring, completely joined. In the same way, cyclic hydrocarbons are the ones where all the carbon is attaching to itself. Terminal carbons are not free but attaching to each other, and there are different possibility of making cyclic carbons. Just 1 carbon can never make a chain, you know that, and 2 carbon also can never make a chain. How can they make a cyclic chain? You can see that 2 ends, how will you add them? How will you make a closed loop out of them? So cyclic compounds only start with 3 or more carbon. 3 or more carbon. Okay, students? So let me try to give you some example over there. First of all, they are also of two types, saturated and unsaturated. Saturated means in a closed chain if carbon-carbon is having a single bond. Unsaturated, in a closed cyclic chain, carbon-carbon is having either double or triple bond. Triple bond is comparatively very rare though. So suppose I want to tell you saturated hydrocarbon with some example. As I told you, minimum possibility of 3 carbon. 3 carbon closed loop. What it will be? Don't you think more of like a triangle? Yeah, that's true. Then putting hydrogen accordingly. And you see, always in comparison to carbon, hydrogen is double. So do remember, saturated cyclic hydrocarbons follows the formula CnH2n. Yeah, that's true. Okay, and what will be the name? I told you in very starting that in very starting we use cyclo. So cyclo for a cyclic chain, prop for 3 carbon, in for having a single bond between it. So what will be cyclobutane? 4 carbon. In a closed chain, hydrogen is double because every carbon demands 2 hydrogen. C4H8. This is your cyclobutane. This is your cyclopropane, cyclopentane, cyclohexane. Cyclohexane is quite important. And you know how to draw a hexagon. Draw a hexagon. And trust me, this is also equally good. You can draw it in this way also. More of like a skeleton structure, right? And you can simply put carbon and hydrogen also. Every vertices there is carbon, and then every carbon is attached to 2 hydrogen. In short, the formula of cyclohexane will be what, students? Cyclohexane will be C6H12, double. Yeah, these are what? Cyclic saturated hydrocarbon. There is saturation. And unsaturated, suppose I drew in front of you that hexagon only. This was hexagon, cyclohexane, right? And what did I do this time? I just put a double bond with 1 carbon and can put hydrogen accordingly. 2 bond, 2 hydrogen. Making 3 bond, 1 hydrogen. Making 3 bond, 1 hydrogen, 2 hydrogen, 2 hydrogen, so on. So how you will name it now? Cyclosame. Hexane for 6 carbon, but ene this time for having a double bond. But there is a special compound here that you should know and will help you in higher classes too. This is a special compound called as C6H6, where I see not a double bond but 3 double bond. In what way? Alternatively. You can always draw it in this sense. Make a hexagon, alright, and then try to put double bond. And how you can put double bond? Double, single, double, single, double. Alternatively, you start putting double bond, double, single, double. And it's totally okay. You can also draw it in this way. It makes sense that I can put double bond on this carbon also. The main motive is double, single, double, single, double. Okay. And what do we call it? It's same only. It just, I wrote it in a short possible way. This has a special name, benzene. What do we call it? Benzene. Every carbon makes 3 bonds, so there will be 1 hydrogen. Every carbon makes 3 bonds, so 1 hydrogen. This is benzene. C6H6, 3 double bond, 3 single bond between carbon and carbon. Do remember this, okay? Now, all the possible type of hydrocarbons are done, and I talked about an alkyl group too, and I told you that when 1 hydrogen is less, that alkyl group is achieved. That can be added to a functional group. That's nothing but an atom or group of atom. And what's the possibility here, students? Possibility that what that atom could be, that's definitely apart from carbon and hydrogen, that could be oxygen, nitrogen and sulfur and many more, and simply called as heteroatoms. We can call them heteroatoms because for them they are different. So heteroatoms apart from carbon and hydrogen, okay? Apart from carbon and hydrogen. Any atom in organic chemistry will be heteroatom. Alright, before moving ahead, just a small thing, students. All of the teachers' efforts will be very much appreciated if you keep on sharing it to your friends and tell them that this channel is equally good and all the teachers taught you guys wonderfully well. So let's try to do that, okay students? And there's a link in the description box pinned by Vedantu. Why that's so important? Because there's a link to get pro subscription of Vedantu, which is super fun and awesome and will help you and guide you to get the best out of yourself. You can come and take classes at our platform, but do not forget to apply this AGEPRO code. AG Ma'am's code is AGEPRO to get discount from 20 to 43% depending upon the duration that you're going to get. It's like 1 month, 3 months and 6 months. 3 months I would say would be the best one right now according to time. So do let me know how can I help you for the same. Alright everyone, and do not miss this opportunity. You will like one step solution of all your problems. You can check it out. Alright students, and now as I said, functional group, atom or group of atom. Ma'am, do we have some example? This was my alkane, right? I removed a hydrogen and so many atoms or group of atoms can be added. Just like halogens. Halogens we also call it halide, that is going to add, suppose chlorine. So this will become CnH2 and plus 1. One hydrogen is gone. Chlorine. And halogens are commonly also called as X group in organic. Different, but yeah, true. Aldehyde is a special group, CHO group, added when hydrogen is removed. Alcohol, OH group. Okay, when hydrogen is removed, I can add OH group, alcohol group. And your very common alcohol that we use in sanitizer too is ethanol, ethane plus all. I'll take an ethane, that's C2H6. I remove a hydrogen and I'll put OH. So that will become C2H5OH. Your ethanol, your alcohol that's commonly used in hard drinks too. Carboxylic acid is that organic acid that we eat in our day-to-day life too, as in terms of tomatoes, in terms of amla, Indian gooseberry, in terms of curd and so many things. Carboxylic acid is the organic acid having this formula COOH. These are functional group, but on a happy note, I can say these are not something that is going to come in your exam this year, okay? But something that I needed to tell you with the help of same is what? Compounds containing the same functional group will be similar. If I have a series of compounds having the same functional group, that's OH, they are going to behave in a similar way. You will be like, ma'am, how come? I'll tell you, because they are constituting a special series called as homologous series. Now, what is homologous series? Homo means same and logous means member. Alright? So, homologous series means a series containing same type of a member. Yeah, that's true. So, how do we get it? Suppose I'm having alkane, I remove a hydrogen and add OH. I got a series of what? Alcohol, and all of them will be having a common group, that's OH, and constituting a homologous series. Suppose I'll tell you CH4, one hydrogen gone and OH is added. C2H6, alkane, hydrogen is gone, OH is added. C3H8, hydrogen is gone, OH is added, and so on. So what did I get? CH3OH, then C2H5OH, then C3H7OH, then C4H9OH, and so on. These are nothing but constituting a homologous series as they are having same kind of functional group. And that's not only limited to my special functional group only. Even your hydrocarbons can constitute a homologous series. The only funda of homologous series to follow some of the property that I'm going to tell you. First of all, as I told, alkanes, alkenes, alkynes, alcohol, carboxylic acid, all of the members can follow a homologous series because these properties should match in case of a homologous series. That's members are different by CH2 unit. Suppose I'm having alkanes entire series. First is CH4, then C2H6, then C3H8, and then so on, right? What did we see? That every member is coming with the addition of CH2 group. One carbon and two hydrogen is extra. Suppose I'm trying alkene series. C2H4, C3H6, C4H8, C5H10, so on. What did we see? Every time one carbon, two hydrogen. Every time one carbon, two hydrogen, and so on. That's extra. They are constituting a homologous series. So I hope the meaning of homologous series is clear. Same member as they follow, same difference of group, that's CH2, and also a same difference in mass, that's 12 unit. When I constitute about these, you see that one carbon contain 12 unit mass, one hydrogen 1 unit, two hydrogen 2 unit. That means every time whenever I move to next and next and next member, 14 unit mass is increasing, whether you talk about alkanes, alkenes, alkynes, alcohols, aldehyde, whatsoever it is. So that's the mass that's going to increase. Apart from that, when we see mass is increasing, it's being a physical property. That means physical property can change when we move in a homologous series. Physical property means melting point, boiling point, density, their physical state. Yeah, that's true. So in a homologous series, that's what that is going to change. That's physical property. You see that I'm moving from methane to ethane to propane and so on. Look at this, mass is increasing, and what effect they are giving to boiling point? That's increasing. Don't say, ma'am, value. Look at the value. Look at the minus sign too. Okay, a boiling point increase, melting point increase, physical property as in physical state increase, lower member gases, middle member liquid, higher member solids. But chemical properties remain same because members are same. Okay, chemical properties remain same because chemical property determined by functional group. If functional group remains same or members are just having carbon and hydrogen, just like in normal hydrocarbons, they'll behave in the same way chemically. Chemical reaction will be same. They're going to react in the same way. All right. So all the points are super clear. Constituting a homologous series, same kind of a member, same chemical properties, difference in physical property, next member, consecutive member having a difference of 14 unit mass and CH2 group mass difference. So I hope it makes sense and you can define homologous series for me too, because ma'am took you to the entire important thing in one way, and will be feeling appreciated if you let me know the homework and all your suggestion and how did you like the session in the comment section. All right, and I trust you guys that you will make this channel a big hit by reaching out to all possible known person in your area, your circle, so that they can come and see, and language should not be a barrier. Okay, students, and as I told you, Vedantu is the best learning platform, and you can choose that by giving a link in the description box. There is a link in the description box pinned by Vedantu. Select your grade over there, 10, select your target CBSE 2021, and you can get your subscription, as ma'am told, for 1, 3 and 6 months, equally best. It's all about how much time you want to spend. Few chapters, if you want to revise, 1 month is totally fine. 3 months, proper thorough revision, crash courses and all. 6 months, a healthy duration, but I think exam, we can't be very sure when will it happen. So you can avail maximum discount like this much if you'll apply this code AGEPRO, and you can connect to me in case of further queries too. This is my email ID given. So keep hitting the like button. Let me see when the video will be done how many likes we can receive, and all the newcomers, do subscribe to the channel for all the amazing videos. Ma'am will come up with something new every time, and some surprise element will try to add. So thank you so much for being here. Do revise and keep coming. Thank you so much. Happy learning.